Students, in the previous standards, you have learned to construct line segments, angles, triangles, and quadrilaterals. Today we will learn how to draw the incircle of a triangle. Let's do a fun exercise. I have cut a triangle from paper here. Hold one of its angles between your fingers and fold the triangle along its angle bisector. Let's call this fold as fold 1. Ensure that angle C is divided into two equal parts. Similarly, fold the triangle along the angle bisector of angle B. Let's call this as fold 2. The point where both folds intersect, let's mark that point with pencil. Let's name this point as D. Now, draw a perpendicular from point D to the base BC. Now, taking DE as the radius and D as the center, let's draw a circle. Observe this circle. Now, let's perform the exact construction using a precise method. Draw any triangle. Let's name this triangle as triangle ABC. To draw the angle bisector of angle ABC, take sufficient distance in the compass and draw arcs from B on sides BA and BC, making points B2 and B1 respectively. Taking a distance greater than half of BC, let's draw an arc from B2. Keeping the same distance, let's draw another arc from B1 intersecting the previous arc. Mark their intersection point prominently. Draw a ray joining B and this intersection point. This is the angle bisector of angle B. To draw the incircle, angle bisectors of any two angles would be enough. Similarly, let's draw the angle bisector of angle ACB. To construct incircle, it is sufficient to draw angle bisectors of any two angles of the triangle. The two angle bisectors intersect at a point which is labeled I. Now draw segment IE perpendicular to BC. Taking IE as the radius and I as the center, let's draw a circle. The incircle of a triangle is the circle that touches all three sides of the triangle from inside. The center of this circle is called the incenter, denoted by I. Now observe the circle drawn in the previous activity of paper folding. Paper folding activities are useful for geometric construction activities. Now identify the type of triangle and locate its incenter. That's correct. Regardless of the type of triangle, its incenter always lies inside the triangle. Now, Let's construct the circumcircle of a triangle. To draw the circumcircle, we need to construct the perpendicular bisectors of the sides of the triangle. First, let's draw any triangle. Let's name this triangle as triangle PQR. To draw the perpendicular bisector of side PQ, take a distance greater than half of PQ and draw an arc with point P as the center on both sides of the segment. Repeat the same process with point Q as the center. Keeping the same distance, draw arc to intersect the previous arcs. Label the intersection points L and M and join them to draw the perpendicular bisector of segment PQ. Let's name these points as C and D and join them. The two perpendicular bisectors intersect at a point O, the circumcenter. Measure the distance from O to P, Q and R using a compass. What do you observe? OP is equal to OQ is equal to OR. All are equidistant from point O. OP, OQ and OR are radii of a circle. The circumcircle passes through all three vertices of the triangle. The center of this circle is called the circumcenter, denoted by O. Now, let's draw an equilateral triangle with each side measuring 6 centimeters and construct both its incircle and circumcircle. Finally, we will calculate the ratio of the radii of these two circles. Now, draw an equilateral triangle with each side of length 6 cm. Let's name this triangle as triangle XYZ. Let's first construct the angle bisectors of two angles. Now draw the perpendicular bisectors of two sides. Let's take the intersection point as the circumcenter and using its distance to any vertex, draw the circumcircle. Measure the circumradius R2 and calculate R1 is to R2. Let's take the ratio of R1 and R2. From the figure that we have drawn, we get R1 is equal to 1.7 centimeters, R2 is equal to 3.4 centimeters. Therefore, R1 upon R2 is equal to 1.7 upon 3.4 is equal to 1 upon 2. Therefore, R1 is to R2, the ratio comes as 1 is to 2. Children, with the help of these methods, practice to draw incircle and circumcircle for different types of triangles. What did we learn? The incircle of a triangle touches all three sides from the inside. The circumcircle passes through all three vertices of the triangle. To construct an incircle, we use angle bisectors. To construct a circumcircle, we use perpendicular bisectors. In an equilateral triangle, the incenter and circumcenter coincide, and the ratio of the radius of incircle to the radius of circumcircle is always 1 is to 2. Exercise. Construct the incircle of triangle XYZ given angle Y 80 degrees, YZ equal to 6.5 centimeters and angle Z is equal to 60 degrees. Construct the circumcircle of triangle PUN where angle U is equal to 90 degrees, PU is equal to 4 centimeters and UN is equal to 3 centimeters. Determine the location of its circumcenter. Construct both incircle and circumcircle for triangle NMS with NM is equal to 7.5 centimeters, angle NMS is equal to 100 degrees and MS is equal to 5.7 centimeters. Find the ratio of the circumradius to the inradius. Prepare a table summarizing the position of the circumcenter based on different triangle types.